Hello and welcome to the next Shell Eco Marathon virtual learning session with Altair Engineering. My name is Norman Koch and I'm the Global General Manager of Shell Eco Marathon. I want to start off by thanking all of you for your flexibility and understanding as we evolved the Shell Eco Marathon this year due to the impact of COVID-19. As the situation continues to change, the health and safety of our Shell Eco Marathon participants and of course our organizing teams remains our top priority. Given the current status, we're excited to have you all with us in this new digital environment as we kick off the virtual learning sessions, all from the safety of your homes. Today, you'll be hearing from Eric Larsen from Altair Engineering about fast meshless analysis. Altair is a global leader in software and cloud solutions in product development, high-performance computing, and data analytics. Altair supports Shell Eco Marathon by supplying licenses, training, and support for Altair HyperWorks to all teams competing in Shell Eco Marathon. Eric is the Technical Account Manager for Education in Altair Engineering, and he's been working for Altair for over 13 years. He studied mechanical engineering at Michigan Technological University and has 30 years of experience in product design and analysis. So welcome, Eric, and we look forward to hearing from you in just a few moments. But before we get there, just a couple of housekeeping comments on this call. Of course, we want to make this call as interactive as possible. So if you have any questions throughout the presentation, please go to menti.com on your browser and enter the code shown below on the screen. On Menti, you'll be able to post your question, but you can also see the question of others and gives them a thumbs up so that they rise on the list and we can answer them first. If by any chance you have any issues entering Menti, you can also post your questions in YouTube comments on the right of the live stream once you're logged in to YouTube. Eric from Altair will then at the end, after the presentation part of this session, answer all your questions. And please, let's give him a hard time and ask really tough questions to Eric. As you know, this is a live stream, so if for any reasons we run into any technical difficulties, please bear with us while we sort out the issue, and we will be back with you then. That's pretty much all from me now. I'll hand this over to Eric from Altair, who will officially kick off the session. Eric, it's all yours.
Excellent. Thank you for that kind introduction, Norman. And I appreciate the challenge. I look forward to seeing if people can stump me. And if you do find yourself stumping me, we may encounter some of those technical difficulties. May just have to sneak away. No, I'm just kidding there. But I do look forward to your questions. Happy to help you in any way that we can. So just a bit of background. Altair has been a proud supporter and sponsor of the Shell Eco Marathon for 4 years now. But even before that, we have been supporting teams, super mileage teams, pretty much any form of competitive design team, providing them software support, providing them free licenses, for providing them sponsorship, trainings, mentorings. And we sponsor a design award in the Eco Marathon. And we have a tremendous commitment to education and have for many, many years tried to assist in any way that we can students and their teams, and we're very proud to do so. At the end of my demonstration, I'm going to go through a description as to how to get your hands on the software, how you can sign up for a sponsorship, and how we can get you up and going with our software. So with that said, I am not going to bore you with any slide presentation. We're going to get directly into the software. You're going to find it is that easy to use that in the relatively short time here. This demonstration probably won't last much longer than about 30-35 minutes because the software is that easy to use, and I think you're going to be pretty impressed with the speed and ease of getting some pretty impressive finite element analysis results, FEA results, with our unique meshless software, SimSolid. So let me transition right over here to the software. This is the interface to SimSolid. It's relatively straightforward. We just simply need to come up here to the project, and select import from file. And that's where we're going to be able to import our geometry. And if I take a quick look down here in the corner, you'll see that we support many of the popular CAD packages out there. So a number of different CATIAs. We've got ProE here, SolidWorks, Inventor, and UG. And then for anything that's outside of that, we support the standard intermediate format. So you see Parasolid here, Step, and I'm sure there's an I just hiding in here somewhere. But of course, the best would be Parasolid or Step outside of a native format. And in fact, the file that I'm going to bring in here is a step file. So as you can see here, we have dronebody.step. I have a modified one. We'll get to that in a little bit to show you some of the really cool advanced features of SimSolid. But I'm just going to double click on that. And a couple things are going to happen. You'll see that little thing go across the bottom. That can take longer if we've got a more complex model. But it opens up relatively quickly. And now we've got the model in there, just a top-down view. And automatically, this is going to pop up here. And what this is our gap and contact wizard, I guess we'll call it. So what SimSolid is going to do is when we have a part that consists of, or an assembly that consists of multiple parts, it's automatically going to stitch those together. And you see we have some kind of odd numbers here, 1.1165 and 0.55825. It's actually taking a look at the geometry and determining an appropriate tolerance for determining gaps. So how far away can two parts be before it truly considers them two entirely unconnected parts? And penetration, how far can two parts penetrate each other and still allow the software to connect them together and not deal with the penetration? And we have some options here. We can go to change the resolution level, normal, increased, or high. Or we can change the tolerances. What I suggest is just leave the tolerances, leave it at normal initially, click OK, and as quick as that, it's going to connect everything together. And then just take a quick tour of your part. You'll see that once we're together here, once we have everything together, it added this connections here. Underneath the assembly. We'll come back to the assembly in a second, but if I click connections, it's going to say regular connections, and now I can scroll through here and take a look at all of the different connections we have. And if I click on one of them, what it's going to do is it's going to highlight the two parts. So this drone body, this arm is coming in, and this kind of purpley looking part is one of the two connections, and this kind of teal light blue part is the other, and then these little red dots represent the connection between them. So it has connected these two parts together, and I can go through and I can inspect these connections. So you can go through, you can kind of take a tour of all the different connections if you want to. It usually does a pretty darn good job of connecting everything together. It's really only when you start experiencing potentially a bad geometry that's a little bit too far apart that you may run into some issues. But in every case that I've experienced, at least, just leaving it on the normal, it's done a fine job of connecting it together. It's really only when you have kind of some sloppy geometry that you're going to experience some potential problems. So as long as you're diligent about making good geometry, you'll be fine with connections. Excuse me. And now you'll see we break this into a project. So we've got this whole project here, and you're going to find that we're going to have multiple design studies under this project. But up here at the top, we've got our basic units. So I can come up here to units, and then I can indicate which unit system I want to be in. And I'm gonna stick around in SI, so my millimeters. And I can change the individual units within that unit system. So if I'd rather be working in centimeters than millimeters, I can change that. This does not affect anything with the part. It's just going to adjust or adapt all of the units in there to the new unit system. So I'm not taking the part and making it 10 times bigger or 100 times bigger or 1,000 times bigger by going from millimeter to centimeter to meter. I'm just changing the reporting and the values, the numeric values, not the overall size of the part. And then, of course, I can change to IPS if I want to, and then I'm in inch, pound, seconds. And that also is not going to affect the part. It's just going to change the values that the numbers are being reported in. And then default material, I could have set that, and then what it will do is it will automatically assign that default material to my part. I don't typically like to do that. I'd much rather assign my materials separately. And we'll get to that in a second, get to the assembly in a second, but just a couple of other settings here. If I come up here to the top, geometry import settings. The geometry import settings, there's not a lot, resolution, enhance, fine, custom. Again, I leave it at standard unless I have encountered a problem, which I haven't yet, and then you can change that, and it will just, it'll grab things. Usually it's when you have large deviation, or not large deviations, but a large range of sizes, very small parts to very large parts, and you don't want to lose the resolution on those small parts. But the most important thing down here is import materials. If you are using a CAD package that supports the definition of materials, this will import those materials in, and you don't have to assign them in SimSolid. I do not. I just have a simple step file, so I'm going to have to assign the materials manually. The next thing is the standard mouse controls. My left mouse button is doing the rotation. So I let go of it, I move it over here, and that allows me to kind of rotate from this side, to let go and come to this side, rotate here. My right mouse button is controlling the panning and then zooming in and out with my scroll wheel. But that also, if I come up here to my mouse settings, we have included in here, again, kind of like we had with Inspire, if you were with us for the Inspire, a number of different popular CAD packages, and by selecting one of those, it will adapt the mouse controls to make sure that that it's similar to or in the same definition as the CAD package you're in, to make that transition from CAD into SimSolid as seamless as possible. And then a description is what each does. Okay, so there's just a few more things, kind of the visualization here. These are our visualization modes, so show parts shaded, or show them wireframe. I like this one right here, this button right here, excuse me. This button takes and changes the colors of each one of the individual parts, so it kind of allows me to visualize the assembly in all of its individual parts. I may not, without this, I may realize that actually this arm is made up of 3 different parts. I can select them, but this is just a nice, quick visual way of doing it. And then this option right here turns on edges. I don't normally like that on. We kind of get this step effect, so I typically keep that off. And then we have translucent, so it allows me to kind of see inside there. And this is a nice one, this clip assembly with plane. So what it does is it puts a clip plane on there. And if I hold my control key and now I scroll my mouse wheel, let me actually turn the colors on here, and let's zoom in. So it's going to take that clip plane and it's going to drag it on down. Or if I hold my control key and I use my left mouse button, I can actually take that clip plane and change its angle there. And if I mess up and I don't get the angle I want, I just turn it off, turn it back on, and again, and it goes to the XY plane. Some other things here, we've got measurement. So if I need to take a quick measurement on my part, we just kind of click there and click here, and now it tells me, okay, the distance between those two is 189.428 millimeters. So I can get some quick measurements on my part as well. Okay, so that's kind of the tour of the interface here. What we want to do is now get down to running an actual analysis. And honestly, in the time that I just took to give you a tour of the interface, I could have run 3 or 4 analyses in SimSolid. It's that quick and that easy to do. So I'll come down here, I'm going to open up assembly, and this is going to be a list of all of the different parts that I have in my assembly. And I can select them here, they kind of highlight, and I'm actually going to take it out of color mode because it's easier to see the highlighted part. So I can select that way, I can select here, and then we'll now it kind of goes in reverse. So if I click this, I can see, okay, this is top plate right there. Another interesting thing is we have this box select here. So if I need to pick multiple entities, I can come to box select, and then now my left mouse button is no longer going to rotate the part, it's going to go to box select. And the really cool thing about the box select is if I drag from left to right, I need only touch a part or grab kind of its centroid to grab that part. But if instead I drag from right to left, it will only select parts that are entirely within the box. So say I wanted to grab these what do you call it, bolts here. If I come left to right, you see I've grabbed a large number of things, but if I instead come right to left, I've only grabbed those socket heads and those sleeves there. So that's a pretty nifty little feature to guarantee that you only select the things that you want to do. And let me just expand that just a bit. Okay, so with my assembly, what I need to do is I need to assign materials, and I can tell there's no materials assigned because the material would show up in here to the right of the part name. So in my assembly, I just come right up here to apply material, and we've got a pretty extensive material library in here. And I'm going to come through, and we'll say we 3D printed this. So I'm going to select ABS plastic and apply to all parts. And you now see that ABS plastic has been applied to everything. If I want to assign things individually, what I can do is, so we'll come here, I'll grab those 4 right there, and now if I come to material, I could say I want these to be stainless steel, and then I can say apply to selected parts. Oops, and I messed up. I said all parts. So let's come here to ABS, apply to all parts, and come back up here to stainless steel and apply to selected parts. And you see now only the parts I had selected have been assigned that stainless steel. So it's relatively easy to add or to apply materials to the entire assembly or to individual parts. Okay, so now that's taken care of, and I'm pretty much done setting up my model. The geometry's in good shape, my connections are all made, I've assigned materials to everything, so now it's time to start preparing an analysis. And preparing an analysis is crazy easy within SimSolid. I just need to come up to these options here. So here is my linear structural analysis, modal analysis, dynamics, and thermal. Start off with linear structural. I'll click this and I'll just say, excuse me, structural linear. And it's going to now add a study under here. So it's going to add an analysis under my design study baseline. And it's going to be structural. So now that I'm in the structural, along the side here, I have all the things that I could possibly need to apply to this. So I've got immovable support, slider support, hinge pivot, spring support, my pressures, forces. So all the possible things that I would need to add. So I'm going to start up here with an immovable support. So this is how I'm going to ground my part, how I'm going to keep it from moving. And I need to turn off box select. I always forget to do that, which means it won't rotate properly. And there we go. Okay, so now I need to come through here and tell it what I want to apply it to. Do I want to apply a face, an edge, a vertex, a spot? So I'm going to put it on a face, and I'm going to apply my immovable supports to the bottom of these feet here. So they turn orange when I select them. And don't worry about the fact that when I select a new one, that one stops being orange. The fact that it's in this list here is all I need. So I've selected those right there. And I click OK. And now it goes and puts these little yellow kind of dots, little X's, little marks there. And now I know I've got supports there. So this is now held on the bottom of this. And what I'm going to do is come up here, and it's very tough to tell unless I get at the right angle, but I've got an edge in there, and I'm going to come to my force displacement, and I'm going to apply that to an edge, and now that I go, there it is, now I can see it, and I'm going to select that edge right there. So we're going to simulate maybe the electronics or something being applied there. And now I just have to specify the direction that my force is going to go in. So take a quick look at my triad down here. Looks like I want to be in the negative z-axis, so I'm going to come down here and we'll put negative 100 newtons of force onto that. I click OK. It doesn't look like anything happened, but because it was negative, the arrows are going down, and I can see inside there. I've got these little pink arrows, and they're on that edge. And so that's it. I've got my constraints down here, so they're holding it in place. I've got my force applied to that. I'm ready to go. So you can see how quick and easy that was to set up. Had I not been talking through the entire thing, it would have just taken me a minute or so to get everything set up. And now this is where the true power of SimSolid comes in. I'm going to click this Solve button. And we're done. That's it. That was a structural analysis on this part. In fact, if I come here and say info, you can see, oh my goodness, that took a whole 6 seconds to run an analysis. That is the power of SimSolid. 6 seconds to run a structural analysis on this part. SimSolid is a meshless analysis system. It is a geometry-based analysis system. I think people tend to refer to it as FEA because that's what we've always called it. But this is not finite element analysis. This is a whole new style of structural analysis based on geometry. And as a person, I think Norman mentioned I've been 30 years in the industry, and I've been running FEA that entire time. And this was a big leap of faith for me to be told that the FEA and the element analysis that I've been doing for decades, now I can do it without elements. I will honestly admit it took a little bit of convincing for me, and I ran many studies against parts that I meshed and did the old-fashioned way and did the way that I'm used to, and then did them SimSolid. And I will tell you, I'm a believer now. It works, and the results I was getting were comparable, were almost identical to the results I was getting with the finite element analysis method. And an FEA on this part, a standard FEA on this part, would not be difficult. But we're talking going from maybe 2 minutes of analysis down to 6 seconds of analysis. So we are going. We're talking orders of magnitude of change in the time. But enough about that. Now that I've got the result here, let's look at some pictures of it. So all I have to do now, I highlight my result, I click result plot, and I get a list of all of the different types of results I have here. So we'll take a look at displacement. Click that. I get a color contour plot of my displacement. I got my legend over here indicating what they are. I can click the play button, and it will play. Just like in other softwares that we have, it is automatically scaling up the displacement. Don't think that 100 newtons of force on this is going to cause your drone body to do this little weird spider dance here. So I can change that deformation scale factor. I just click this button right here, so I can make it really deform, or I can remove the deformation, or click show true deformation. And now you see, I can see a little bit of deformation, but it really takes scaling in or zooming in. So we scale it up automatically. It just allows you to see it a little bit better there. And what I'm going to do here, before I do anything else, is I'm going to come down here and I'm going to take a little bookmark snapshot of that. Click that, and it gives me this little bookmark down here. We'll come back to these, but this is going to play a huge role in what we're going to do when we start talking about different modifications and design studies on this. So we'll just leave that there for right now, but I promise you we'll come back to it. And now I'm going to click here, and I'm going to come to von Mises stress. And now we can see the von Mises stress. So we're seeing stress in this area in here. And just like we could with the displacement or the deformation, I can change the deformed shape. I can change how it's going to report the different amount of colors, whether I want it distinct colors or a smooth colors right there, 6 colors versus 12. I can show min and max. I can come here and lock the min and max bounds, and I can set the output units if I want. And then I can also speed it up, slow it down, and increase the number of steps that it goes through. And just like I did with the displacement, I'm going to come here and grab a quick snapshot of my stress, and now I've got that. Actually, let me come here. Let's delete that, and I want it shown with the 12 colors. There we go. Okay, perfect. Okay, so that's it. First analysis done. Not done with the demonstration yet. It's still got some really cool things to show you, but that's how quickly I can run a first analysis. So let me get out of here. Just come up here, close that down. And now another thing that we commonly would want to do is come up here and do a modal analysis. So modal analysis is crazy easy. I just need to come to here, select the number of modes I want to find, click OK, and then run the modal analysis. And just like that, there we go. Now I got a modal analysis. This one took 3 seconds this time. And now I can come here and contour my result, do displacement magnitude, and I can see all the modes that we have here. So the first, because this was an unsupported free modal analysis, the first 6 modes are our rigid body modes. We ignore those. And this is our first real mode. In fact, SimSolid was intelligent enough to move you down to the first real mode. And I can see the mode shape, and I can see how this does. So now I've got my modes there as well. So I know my frequencies, I know my shapes. Perfect. So that's the standard type of structural analysis that we want to do. But then also we could do, say, a thermal analysis. So I know that I can come over here, I can click thermal analysis, it now puts a thermal, and you see that each one of these different studies is being put under my design study. So each one is being considered its own independent, and I can come to each of them and review that. But we'll come here and we'll do a thermal analysis, and I'll say, okay, I've got a heat load, and I'm going to apply it to a face, and I'll pick that face right there, and I'm going to say this is, say 100C, really hot. Okay. And I know I've got a thermal flux going on in the bottom here, so I'm going to come to my flux, and we'll say that this face, we'll say this is taking heat away. We'll say, you know, negative 20 watts per meter squared. Click OK. So now we've got that coming off of there, and that's it. Let's run a thermal analysis, and let's see how the heat works through here. So that's done. Let's take a look at the temperature. And so now we can see, it's a really hot spot there. This is doing a nice job of pulling that heat away from there. If I want to, I can look at the thermal flux. So yeah, beautiful. So now I've got a thermal analysis in here. And adding different analyses is that simple in SimSolid. And in just a few minutes, I've done some pretty complex analyses. But I think you'll find that where some of the true power lies within SimSolid is its ability to do design studies and modification studies. So I'm going to come up here and I'm going to say project, import from file, and now I'm going to grab this drone body modified, and I'm going to click open. And it'll take a second to import it in. Again, I get my little connection wizard here. I'm going to leave everything the same. It worked fine for me the first time, so I'm going to click OK. And now I've got a design study 2. But notice what's happened with my design study 2. My structural, my modal, my thermal, all of those were automatically put in there. SimSolid is intelligent enough to realize that this is essentially the same part as I had before. So it knew to go ahead and assign everything just like it was before. And what I actually did with this part is, let me come back up here to structural. If I look at the original part, you see how these arms are pretty thick. I think I want to see if I can save some weight here by reducing the thickness of these arms here. So the only thing that I have to do now is I need to come down here to assembly, and we'll notice if I select this arm, it has no material assigned to it. Because I modified these, so these feet and these arms here, because I modified them, it did not automatically assign a material to them. So the only thing that didn't get the same material assigned as the original part, are all the parts I modified. But again, that's easy to resolve. I just come up here to my apply material, and I'll select my ABS plastic, apply to all parts, and okay, and now I'm good to go. As simple as that. And now I can come to my structural. The one thing that I have to do is I actually have to run the analyses. It imported from my previous all of the different setups, so everything is set up the same, but I still have to come to each of these and click run. And then I'll come to my modal and click run, and come to my thermal and click run. And now I have a brand new study for my design modifications. And I can come to my structural, I can click result, but if I click my bookmark here, now it takes my exact settings from the original study and applies them to this study. So I can see I'm looking at displacement magnitude for my, there we go, for my new part by clicking result. So I can do a direct comparison. So I can see here, okay, that's my new study. This was my original, and I can do a direct comparison between the two, or I can come and grab my bookmark 2. That's my original. That's my new study, and I can see, oh, okay, maybe that wasn't the wisest of choice to thin those arms out like I did that there. Maybe I'm not getting the same the same structure that I had, the same results I had before. Maybe I went a little bit too far, and I can take a look at my modal, and we'll see. Okay, I'm at 51495, and my modal here. So you can see I reduced the frequency pretty significantly. So maybe I want to take a third shot at this. I like the weight savings I got because of the thinner parts, but maybe I want to make a quick change to that. So I'm going to right click on this, and I'm going to say copy. And now you can see, now I have a design study 3, and everything, just like it was in the other, is set up. I've got my structural, my modal, my thermal, everything's the same. But with this study, what I'm going to do is I'm going to come to my assembly, and I'm going to click, and I'm going to do control click, control click, control click, and I'm going to come to material, and we'll go a little crazy. We'll say we're going to make these as titanium. And I'm not going to click apply to all parts, just apply to selected parts. Click OK, and now just my little arms there are titanium. We'll say I came across some titanium there, and now I can come to structural and grab my structural and run that. And come to my modal, and we'll run that. And shrink that and come to my thermal, and we'll run that. It shouldn't have any effect on the thermal analysis. But then again, these bookmarks that I put down here, these bookmarks are absolutely amazing when it comes to doing design studies, because I can just come to bookmark, and now I come down to my design study 3 here, click the result, and now I can see the results of that. So I'm at what am I at? 0.48 on that, and my second one I'm at 2. So I significantly reduced the deformation of this part by changing those legs to titanium. Sorry, just need to rub my eye there for a second. And now I can come and take a look at my my stresses. So that's my original stress. My maximum stress was 3.6. In my design study 2, my maximum stress was 6.1. And design study 3, I've reduced my maximum stress. Or did I reduce it? No, there we go. Actually increased it a little bit. Actually, I guess it makes a lot of sense because these aren't going to move as much, which is going to cause a bit of stress in that area there, but still significantly below the maximum that I can support. But most importantly, I've significantly reduced the overall displacement here. So as you can see, using SimSolid, it's very easy to run through a large number of different iterations, different studies, um, and allow you to review potential changes that you make by just simply bringing in parts that you've modified in CAD, or right-clicking and copying and setting up new studies, changing materials. It allows you the time, the ease and convenience of doing what-if studies. It's suddenly saying, what if I went crazy and made these parts out of titanium? What are the effects I'm going to have? In a traditional sense, that could take a bit of time to come up with those answers. But using SimSolid and the ease of use of SimSolid, I can do what-if studies and get a tremendous amount of answers in a relatively short amount of time. So that's pretty much it, other than to say now I can come here, I can save my project as, so I'm going to call this drone body, that's fine. And now you'll see if I come to project, I close that. And now in a day or two or month or week or whatever, I can say open project, come to my desktop here, and I'm going to open up that drone body, everything that I had in there. It's going to take a little bit longer to open up because it's bringing all that, but everything I had in there is there. All my results are still there. I don't have to rerun the analyses. All the results are stored within there, but the entire design study that I had is all right there, all ready to go. And I could just review the results, or I could continue on with doing a study. There are a number of other types of analyses that I can run here: structural nonlinear, superposition, thermal superposition, transient frequency response, random response. We can get you material on this if you contact us and request a sponsorship. That gives us the opportunity to connect with you and get you the material if you want to learn some of these more advanced studies here. But that's just a quick little primer in how to use SimSolid. You see, it's crazy easy to use. It's really fast to get results. I can, even do things like a result graph here. So where is it here? Pick at least two. So I can come here. There we go. And now here's a graph of that, of the von Mises stress along that line. So I can get some amazing information from this, and I can get it in a relatively short amount of time. So that's pretty much it for the basics of SimSolid. What I want to just briefly talk to you about now is how to go about getting a sponsorship from us. And so I'm going to take you to our university, Altair University website here. It's just altairuniversity.com. You'll see right here at the opening page, we've got a free student edition. So we have a student edition of much of our software. We're working on getting SimSolid included in that student edition right now. We do have actually a trial for SimSolid. If you come here and take a look at the products, analysis, I think it's under analysis. SimSolid, yeah, not part of the student edition, but if I click that, I can get a 15-day trial of that. Ultimately, it will be part of the student edition. But if you want to get your hands on all of our software, including SimSolid, the best way to do that is, like I said, come to altairuniversity.com, come to the Students tab here, and down here we've got student competitions. And you'll see we've actually have a lot of other things here. We've got some great ebooks that you can get your hands on that cover the entire gambit of analysis. These books are absolutely amazing. But if you come down here to student competition and request sponsorship, so you'll see here, and look at that right there, Shell Eco Marathon. go ahead and just usually we have the team captain or team representative or whomever be the one who signs up for this. First name, last name, email, college, university. Take you 5 minutes to fill this out, and we will get you a sponsorship. Somebody will be in touch with you typically within a couple of days, and we can get you your sponsorship, which is free licenses. We'll get those to you real quick. You typically within just a couple of weeks, if even that long. It really just depends upon how long it takes to get all the paperwork processed. But the sponsorship is going to get you all of the software that we have. You are going to get the same level of license that we give to or sell to our corporate customers. Plus, it's going to get you contact to us. It's going to get you the ability to work with one of our support technical people. In many cases, it's me that's helping you, coming out, doing classes for you, doing mentorship, helping you out on any projects you're working on, giving you the ability to bounce ideas off of us, ask questions. Really, we treat you like a corporate customer and not like a student team. We want to help you succeed. We want to help you do better in these competitions, and most importantly, we want to provide you the tools that are going to help you get a job when you get done with your education. So please do get in touch with us. Apply for that sponsorship. We'd love to help you out. We'd love to work with you, and we will all be back together hopefully next year with live competitions again, and just realize the improvements that you can make to your designs, letting us help you along the way. So that's pretty much it for demonstration and for what I wanted to talk about. I guess we'll now move into the next segment, which is let's see if we can stump Eric. Hopefully, Norman has got some good questions coming in there, and we'll see if we can help you out. So thanks for your time on this, and now I look forward to hearing your questions from Norman.
Yeah, thanks very much, Eric. And indeed, the questions have been coming in, but by all means, please, if you have any questions for Eric, please go to menti.com and enter the number on the screen and enter your question, or give a thumbs up to a question that has already been asked, or equally put your question in the comments box on YouTube. So very, very visual and very hands-on tutorial from you, Eric. So thank you so much for this. And the first question is obviously from somebody who's been following your webcast yesterday and asking the question, the interface seems to be quite different from Inspire. Do you plan on updating SimSolid to match Inspire's interface?
Yeah, so excellent observation. SimSolid was an acquisition of ours. SimSolid was not natively developed by our developers. One thing that the management of our company does, and from the highest levels, is they're always looking for the next revolution in technology. And so we came across the folks who made SimSolid, and fortunately were able to work with them and come into agreement to bring them into our fold and provide this software in even broader market. But that does mean there's a little bit of a discrepancy between the interface, and it's a little bit different. So I don't know 100% what the plans are in the future. I know that all of our softwares are moving towards more of an Inspire-based interface. I will tell you, though, and this is another situation here where I'm going to switch over to my other to my software here. So I just need to bring up Inspire. I'm going to actually take a step back to yesterday. So yeah, if we can go to my software here. So this is the Inspire interface we worked with yesterday. If you were in attendance, but I will show you if you come here to File. Preferences, and you come to run options, the default analysis solver is OptiStruct. But I do, within Inspire, have the ability to switch over to the SimSolid solver. That's with some nice alliteration there, SimSolid solver. And what that's going to do is it's going to now utilize SimSolid solver to do the analysis within Inspire. Now that means we're limited to just the structural analysis. We don't have the optimization capabilities with SimSolid. It's just the structural. But if you're enamored, as I am, with the Inspire interface, we can actually do SimSolid speed analyses within Inspire by switching to that, as long as we don't want to do the optimization. But that means that we're just doing the analysis there. Ultimately, I suspect that we are going to do some work on the SimSolid interface, kind of bring it more in line with everything that we have, so we can have these other things here. But I don't know what the future truly brings. I don't know what their plans are. But I would expect great things, because every single one of our softwares is looking more amazing with every release.
Thank you, Eric. A question about the functioning of the analysis. How are the equations governed in this type of analysis? Just meaning the FEA uses equations and data from neighboring nodes, but how is it solving the boundary conditions in this solution?
You think they tell me that sort of information? I'm not important enough for that. No, I wish I could answer you, and we'll say congratulations, you managed to stump me. But the mathematics behind it, I don't know. Quite honestly, I don't know. The people who developed this, they have come up with some way of managing the geometry. I know there's a number of different methods that they kind of string together. At first, I was asking. I don't know if you're familiar with the P element method. It's a parametric element that you change the order of the equation that defines the edge. I had asked if they were doing that, and it was similar to that. It was along those lines in some cases, but other shapes, depending upon what the shape is, they've got equations that manage that particular type of shape. So my understanding is it's a conglomeration of a number of different techniques depending upon the shape of the individual solid. And I don't want to say, oh, it's voodoo magic, but it's amazing what they've done and how quickly they can do it. And I will just state again, I'm the biggest skeptic you will ever encounter. When somebody tells me that the paradigm of what I've been doing for decades now is beginning to shift, it took a bit to convince me. But I will tell you that I ran studies. I took a look at parts. I did it the way I'm used to, and I've done it in SimSolid, and those numbers are coming in very, very close, well within the standard errors the standard deviations that we expect in finite element analysis. So, like I said, I've been converted to a believer, and I wish I could tell you more, but A, I'm not that important, and B, I'm probably not even that smart. So.
Yeah. Can you say something about the solving time and whether the solving time depends on the processing power of the PC that's being used?
Yeah, so there's absolutely it is going to be based on the PC. But even and I've got a pretty decent machine. It's a relatively new machine. So mine it's pretty high end in that regard. But I've worked with SimSolid with many students, and I know that many students are on a budget and are not able to get the size of the computer, the laptop that I have, and it runs really quick. So mine took 6 seconds. On a slower PC, it may take 10 seconds. So we're not talking. It's almost doubling of the amount of time. But when you double seconds, it's not going to impact that. And this was also a relatively small model. I mean, I've seen models that have taken a couple of minutes to run, but realize that if it's taking a couple of minutes to run in SimSolid, you're talking potentially hours to run in a standard FEA solver. And also, I don't, because of the way that SimSolid solves things, I don't have to worry about going through and refining my geometry. If I've got a geometry with a ton of little radii or little features or little things like that, in a standard FEA system, I'm going to have to spend a very long time going through and just refining and cleaning up and fixing the geometry before I can even begin the act of running the analysis. So you've got that added time there too. So I wouldn't worry about the power of your machine. It may slow it down a little bit, but when you're doubling the amount of time and you're talking seconds or minutes, we're not talking a tremendous increase. So don't worry about that.
That's clear. And will very large models have a similar extremely fast solution time, or can you give an example about model times and solution time, model size and solution times?
Yeah, absolutely. So I'll tell you, I can't mention the customer I was working with because confidentiality agreements and such. But I was working with a customer. We had an extraordinarily large, very complex model. It was an aviation model, and they wanted to run some modal analyses on it. And they were running an analysis, and it went in a standard FEA package. It was taking them uh, well over I think it was like 12 or 13 hours to process one modal analysis on that model. We ran it in SimSolid. We started it. We went to lunch. By the time we came back, it was done. We took a quick look at it. It took like 16 or 17 minutes to run. So we dropped that, close to a factor of 60, from 13 hours to 16 minutes. And 16 minutes, interestingly enough, when you start talking about SimSolid and something taking 16 minutes, everyone's like, oh, 16 minutes to run in SimSolid. But again, that was a 13-hour. So yes, there are large. Not everything you run is going to take 3 seconds or 6 seconds to run, but you are talking orders of magnitude in difference in analysis time. And I cannot emphasize enough that not only is it analysis time, we didn't have to touch that model. We brought it in. It took about 5 or 10 minutes to actually bring into SimSolid, but then we reran it. We did not have to alter any geometry. So we dropped 13 hours down to 16 minutes, and we dropped probably 3 or 4 hours of model cleanup time down to clicking a button and running it. So
yeah, thank you.
Yep.
We get a couple of questions on the sponsorship that Altair provides to Shell Eco Marathon students. Can you just say again on what basis do you accept the sponsorship from teams?
So we've got some pretty rigid requirements. You have to be a team. No, that's pretty much it. If you're a team, you get a sponsorship. So yeah, we call it a sponsorship application. It's more like a sponsorship sign up. There are no requirements other than you have to be a competitive design team. Oh, and you have to be a university student. So there's 2 requirements there, I guess. We open our arms to everybody. We are not looking. We, as a company, in our involvement of education, we look at how we can help, not try to filter out why, and try to figure out what we want to help, and only we want to help these people. We're going to help everybody. So you sign up, we're going to get in touch with you. It's not an application. It's not even an application. It's more of a sign up. You just have to be a competitive design team, and you have to be a university team. That's it. That's our sole requirements.
Yeah, and also another question about the license. Do teams need a separate license for SimSolid, or does it come with HyperWorks?
So if you get the sponsorship, it's going to be under the same license that HyperWorks runs under. We've got a corporate license that all of our softwares fall under that license, and we'll work with it. If you get the sponsorship, you're going to get the same level of license that our corporate sponsors or our corporate customers. But like I said, with the student version, you won't be able to run SimSolid. You have to get the 15-day trial. But if you've got the corporate or the sponsorship license, you'll be able to download any. You can sign up for our Altair Connect website, and you can download any of our softwares and install it.
So it's all part of it.
Yeah. And sorry,
Yeah.
my little birds are speaking in my ear. I've got a group of people in the background that are helping me out here. So all we can say is it's a computational engine based on the extensions to the theory of external approximations, which are a generalization of finite element method. Wow, that was
that makes it all
pretty
clear, doesn't it?
Yeah, exactly. Okay, well, that cleared it up. Like I said, I don't think I'm smart enough to understand it, but that's what it's doing in the in the background there. So,
but I'm sure you have the advantage. All watching here today, you can watch the rerun, you can watch the recording of this, and maybe then it makes sense. I think that's certainly. I certainly have to go into the recording. You will receive when you have registered for this webcast, you will receive, that was also a question we received, you will receive a link to the recording, and also please share it with your peers, with your colleagues in class or in your team, or anybody at the university who you feel might benefit from this presentation. And again, please send us questions, keep them coming in. Go to menti.com and enter the passcode if you haven't already done so at the bottom of your screen, or put them into the comment box on YouTube. A question, Eric, for you, and that I think relates a bit to dynamic forces. Can I set a time for which the force is applied, and if it ramps or impact, and check the deformation at each step?
Let's see here. So just take a look at here. If we do, just looking at our dynamics of transient analysis. So yeah, just pulled up the transient here. So yeah, I can do a time span for a transient analysis. I can provide the amount of time it takes to come up. I can put in damping. So I have not done a transient in SimSolid as of yet, so I'm just kind of working along with you here. It looks like, yes, I can define it over a time, and time span can't be set to 0. So yes, we can do it over a time. As for post-processing it, I have not done transient in SimSolid as of yet. I've been dealing strictly with the structural, but it looks like we can do some pretty quick transient frequency response and random response analyses as well. Now, as for analysis times, I can't tell you what the analysis time is going to be on there, but I can tell you it will be substantially less than the amount of time that it would take to run in another system. So.
Mm-hmm. Okay. And could you talk a little bit more about modal analysis and its advantages?
Modal analysis. So modal analysis is very important in engineering, because when we design something, it's going to have some sort of resonant frequency. You've probably experienced this if you've ever driven down a freeway or a highway or an autobahn or anything along those lines, and you hit a speed and something starts humming in your car. Yeah, you're going to hear the wheels humming, but it'll excite something, maybe something in the dashboard, or you'll get a squeak of some foam rubbing against something. And literally, if you go just a couple of miles faster, a couple of miles slower, that's going to disappear. So there are aspects in our vehicles, in everything, that have a specific modal frequency, and we don't want those to excite. When you're talking about an annoyance like that, it's referred to as NVH, noise, vibration, and harshness. You want the people who are driving in a vehicle to have an enjoyable experience, and having some sort of hum or annoying background noise at specific speeds is annoying. That's just bothersome. But now think of something a bit more extreme. There are some very, very heavy engines hanging off the wings of an aircraft, and there are some pretty serious devices holding them on. But imagine that engine is rotating and it's doing its job, and if you've ever kind of put your head against the wall of or the fuselage of an aircraft when you're sitting in the seat there, you can feel the vibration. Especially if you're wearing headphones and your headphone touches it, you can hear the vibration. But those engines are sending off a vibration, and if you have a bracket that's holding that engine or something critical on the aircraft, and it happens to have a resonant frequency at or very close to one of the frequencies that the engine is spitting out, you're going to excite that. And imagine pushing a kid on a swing. If you push them at the exact proper moment, they're going to increase their swing, and they keep going higher and higher and higher. Well, that's the last thing you want to have happen to that bracket holding your engine on, because ultimately it's going to fail. So modal analysis is critical to make sure, from a comfort or an enjoyability standpoint, as well as a safety standpoint, that we keep our parts outside of a frequency range that could be excited by the natural operation of a vehicle, because at its best, it's an annoyance. At its worst, it's potentially deadly. So modal analysis is very important.
Yeah. Does SimSolid have any drawbacks as compared to conventional FEM methods?
Just trying to think of anything. I mean, I haven't encountered an analysis that can't run in SimSolid, um, and I'm sorry, I'm just getting another thing here. Main thing is it's based on FEM and not black magic. I probably shouldn't have said voodoo, but sorry. Um, the main thing, or I have not encountered an analysis that it can't handle yet. I would imagine, just like any software or any analysis, you could hit something that it can't run. I have not encountered it yet, so I'm going to say I have not seen any drawback to it, or any limitation to it. But I, I'm not. I'm realistic enough to believe that yes, there probably is some sort of limitation. I haven't hit it. I think any software, any analysis software, is going to have a limitation in that regard. So.
We have also a question here about making the model in the first place. So can you give any guidance? How long does it take to make a model in SimSolid, or should you use a more classic CAD program for that?
You can't. So okay. Congratulations, you found a limitation there. SimSolid can't make a model. You cannot create a model in SimSolid. Unlike Inspire, where you've got limited capabilities, I won't even say limited, you've got some pretty cool capabilities for generating a model, nowhere near the power of a CAD system. SimSolid is purely bring in geometry. There is no ability to generate a model within SimSolid. You have to generate it outside and then bring it in. So think of it as the next step in the process. You do the geometry creation in your CAD, you do your analysis in SimSolid.
Okay. And again, another reminder, we're on top of the hour. We have a bit of time left. So if you have any questions for Eric, please send them in now. In the meantime, while you type your questions either on menti.com or on the YouTube comments box, there's a question. In aviation, do big companies use SimSolid? For example, Rolls-Royce testing, analyzing their turbo design engine.
Yeah, absolutely. Yeah, I've worked with Rolls. I've worked with a number of companies. We actually, and I can't remember the name of the company offhand. We had a success story that one of our customers did using SimSolid, that they were able to do something. I wish I could remember what it was. Maybe the birds in my ear will remind me what the company was and what their success story was. We had a really good success story video on the use of SimSolid. So yes, our corporate customers are absolutely using it. I've taught many of them myself in how to use SimSolid. They're excited about it because of the fact that it reduces so much time in not only the setup but the analysis time as well. So.
And again, we keep getting questions from our participants coming in on the license and on the conditions of the license. There's the question about the difference between a sponsorship license and a student license, and how many days can anybody use the SimSolid on any of these two licenses?
So unfortunately, the SimSolid, SimSolid is not included in the student version. For that, outside of the sponsorship, you would be able to get a 15. I think it's a 15-day license. They may have changed that, but at least last time I looked, it was a 15-day trial license for SimSolid, and that's actually anybody can get that, corporate or student. For the rest of the softwares, and we don't we don't offer all of our softwares in the student version. We offer all the ones that a student probably would use, and some of them do have some limitations to it. Typically, it's a node count limitation using hypermesh and OptiStruct, but even there, it's a very generous node count limitation. But Inspire, under the student license, is completely unlimited. The only potential drawback with Inspire is because it's based on the student license and we have to update it to that. Usually it's about a point release behind wherever we are in our release schedule. But the sponsorship license, if you get the sponsorship license, It is literally the exact same license that we would give to a customer. It's the same license that Rolls is using. It's the same license that Airbus is using. It's the same license that any of our corporate customers are using, and we give you as many of them as you need for your team. You want 3 licenses, we give you 3. You want 10 licenses, we give you 10. And both the student version and the sponsored version are good for a year.
Okay, that's clear. And then we have a question that pertains to what Shell Eco Marathon teams can apply for a sponsorship. So can only teams from the regional events apply, or can also teams who only participate, only in inverted commas, of course, who only attend in the local Shell Eco Marathon events like Shell Eco Marathon India or Shell Eco Marathon Brazil? Is there any restrictions?
Nope, not at all. If you're a team, apply for a sponsorship, and we'll get one to you. Now, outside of the U.S., they would be handled by whatever office is in that in that region. So if you apply for a sponsorship, it'll come to us. We're going to forward that on. Excuse me, I don't know what's going on today. I'm going to clear my throat a lot. We're going to forward that on to the local office, and they'll be the ones to work with you. But we have no limitations as to what type of team or the level of competition, or I mean, even if you're, I don't know if we've ever had that, but even if you're just kind of a local team at your university and you're doing stuff there and not even necessarily competing, we'll still sponsor you. We have no limitations. So.
Thank you. I have a couple more questions. So anybody with any urgent questions, last minute questions, please send them in now. Otherwise, I have a couple of questions to close out the Q&A round here for today, Eric. First is, how do I know my solution is correct?
So you know your solution is correct by testing it and making sure that it does. But even standard finite element analysis, it's a trust level. You have to develop a trust level. You have to put your trust in the mathematics. But realize that it's not just you putting your trust in us. It's not just you putting your trust in the software. We verify our software. So I think it's NAFEMS and a number of other organizations have what they call standard test models. So these are models that they know the answers to. They know the answers to because they've tested them. They know the answers because they've done the mathematics by hand. And any solver company, whether you're talking about standard finite element analysis, whether you're talking about meshless analysis, anybody who is producing any solver, before they're going to go out and they're going to swear to the world that their software is good, they're going to run their software against those test models, and they have to come in within a certain percentage. And we do that. All of our softwares are always tested against models to make sure that the stuff we know the answers to, it's coming up with those answers, and the stuff we don't know the answers to, then we know we can trust. But aside from that, and just something I've learned over my many years, frighteningly long years of experience doing this, is also trust your gut. When you run an analysis, you should always have a relatively good idea just from your engineering experience, your engineering knowledge, your gut feeling of what the result should look like. And if you get a result that differs from that, don't ever just, no matter whose software it is, don't ever just look at the software and say, well, the software told me it's this, so it's this. Trust your gut, because yeah, I've been surprised many times in an analysis where my feeling was just dead wrong. But there's other times when my feeling was dead right and I made a mistake. It happens. So when you get a result, don't just blindly believe in it. Look at it, go and double check your model, take a look, see if you made a mistake. It's really easy to leave a 0 off of a Young's modulus, which has a string of 9 zeros behind it. And that's going to end up with a very bad error. So trust yourself, double check. I think there's a term, it's trust but verify. And then if you find out that you said everything right, then yeah, it's telling you something you didn't know was going to happen, and I've had that happen many times too.
No, that's clear. And another question, is it possible to perform composite material analysis?
So again, just like with Inspire, we are talking about linear isotropic. So you'd have to homogenize that material definition. We don't have the ability to do plies within SimSolid, but people are doing composite material by just kind of homogenizing it and coming up with an equivalent material definition. And also, just like I said, the little birds in my ear let me know that it is our SimSolid is our fastest growing software in the corporate region. There's many industries that are adopting it, and we've got recent videos and success stories from Renault and from a company called Don Burr, and some great successes that they've had with SimSolid. So yes, industry is adopting it, and it's one of our fastest growing softwares in the corporate level. So people are believing it and having success.
Okay. We have a question also. Could you please repeat on how the software analyzes the model?
So it does a geometric analysis, and as my backroom people were telling me, it is a computational engine based on extensions to the theory of external approximations, which are a generalization of the finite element method. It's taking the mathematics behind the finite element method, and it's coming up with generalizations on that. And my understanding when it's talking about generalizations is it has an understanding how different shapes behave. And so it knows that if this shape has been tested and is going to behave like this, it can predict that for the future, for things that are different from that original test.
Okay.
And it's able to make assumptions in that regard, and that's why it can do it so fast.
So now you've said it twice. I don't know what could possibly not be clear. But again, I refer to the rerun and the recording of this program. Does Altair have a program that can run aerodynamic analysis?
I guess it really depends upon what sort of aerodynamic analysis you're talking about. We have CFD softwares that can do flow, so you can get flow over a wing. Drag from aerodynamic standpoint, we've got electronic analysis software, so you can do and analyze things like radar reflection, aerodome. What do you call it? Not reflectivity, but the ability to pass an electronic signal through an aerodome. With structural analysis for aeronautics. So in aeronautical analysis, it's a pretty broad term, but yes, we have softwares that cover every aspect of aeronautic analysis.
Yeah. So very related. A question that has just come in on that is: do you have a student version for virtual wind tunnel, and are there any courses offered by Altair to get familiar with the software?
Yes and yes. The virtual wind tunnel is covered under the student version, as well as you get it in the sponsorship package. And on altairuniversity.com, we have what do you call it, educational packages on there. In fact, it was covered in our educational webinar, which was done last fall, and I believe you can find a recording of that on altairuniversity.com. If you can't find it there, sign up for a sponsorship, get in touch with us, and we can send you that recording. Plus, because of the popularity and the usefulness of it, 100% certain we're going to end up having another educational webinar that covers virtual wind tunnel this fall. And I don't know what Paul is covering tomorrow, but I know he's doing CFD. He may even be talking about virtual wind tunnel when he does his stuff tomorrow.
Yep.
Sorry. Just double checking here. So virtual wind tunnel. Interesting. Okay. I have to walk my statement back. So virtual wind tunnel is not included in the student edition, but it is included in the sponsorship package. So I do apologize for misleading you there. That's why I've got people in the back room who are keeping me honest. So. But you can check
if our Shell Eco Marathon teams apply for a sponsorship version, they can have the wind tunnel software included.
Absolutely. Yep. Yeah, it is absolutely included with the sponsorship because, like I said, that is the exact same version as the corporate level of software. So.
And we have still a quite quite some intriguing questions about the methods of SimSolid, but could you talk about how it's different from HyperMesh and how it works in comparison with HyperMesh?
So HyperMesh is a traditional finite element analysis preprocessor. There's nothing. So I'll say this: there's nothing you can do in SimSolid that you can't do using HyperMesh and an appropriate solver. The distinction is you can do it faster and you can do it quicker, or faster and quicker, the same thing, faster and easier in SimSolid in the things that SimSolid can handle. So there are many, many types of analyses that SimSolid can't do. It is a subset of the broad reach of the types of analyses. So for instance, optimization. SimSolid can't do optimization. Inspire can do optimization, but has a limited amount of optimizations it can do. But if you jump to HyperMesh with OptiStruct, you can do all of the different optimizations that OptiStruct can handle. So each one of our softwares, and it kind of goes with the type of package that it is. Each one of them is a simplification of a broad range of tools that our main enterprise level softwares can handle. And as long as the type of analysis, the type of study that you're looking to do can be handled by that, then by all means use the easier to use software. But if you need all of the different things, everything that we can do, you have to go to HyperMesh and you have to go to OptiStruct. And that does mean, I mean, I'm not going to lie to you, it does mean it's going to be a greater investment in time. It's going to take some time not only to learn the software, it's going to take some time to ramp up. Any true full power FEA preprocessor and solver it's a complex software. It takes a lot of time. It's not, you can't just pick it up like you can with SimSolid and start running things. But the payoff for that is now you have the entire spectrum of all the different solvers that you can use. And just as one more supplement here, virtual wind tunnel will be covered in Paul's presentations tomorrow. So if you're interested in that, please, by all means, attend the virtual session, the virtual learning session tomorrow. Paul, one of our amazing CFD guys, is going to be covering virtual wind tunnel using UltraFluid X. I'm probably stop by and watch that myself. So I can learn.
Thank you.
No problem.
Thank you so much. And huge thank you to you, Eric. It looks like we had very good questions today. Only one that you sort of a little bit had to use the help of the back room. But thank you, everybody on the call, very much. This wraps up the Shell Eco Marathon learning sessions for today with Altair. A huge thank you to Eric and the whole team at Altair for your time and for your helpful presentation. They were very insightful. I really enjoyed it with you today. Many thanks again for everybody on the line tuning in and taking part. As Eric already mentioned, there are more virtual learning sessions coming up in May. The first one already tomorrow, where we will be hearing from Paul Over, who is a student of Hamburg University of Technology, as well as an Altair student ambassador. And he will be talking to us about lower energy consumption and better performance with optimized aerodynamics. So if you haven't registered yet on the website, please do so. We'd love to have you to join. And for today, thank you very much and goodbye.